All right, we're super excited to be here. Thank you all for coming back and leaving the line for the Hasbro 3D printed action figures. I know that seems to be like the central draw of Digital Factory this year is like getting an action figure made. Have you already stood in that line, Kim?
Already done it.
You already have done it. All right, so we are super excited to be talking about next-gen design strategies, trying to define like what are next-gen design strategies and how they connect to smarter manufacturing. What I want to do with this time is really try to like push your thinking and use these three great speakers to push your thinking. Like we know that Digital Factory does not attract the newbie audience. Like this is a pretty sophisticated audience. Like, can you raise your hand just out of curiosity if you're here in the seating area? Even if you're way in the back, in the like maybe taking a nap section, raise your hand if you consider yourself a designer or design manager. Weirdly, those are all the people in the back. And then how about more like prototyping, production, manufacturing people? All right, and then other, raise your hand just to show us that you are awake post-lunch. All right, what are some of the other people? Media, all right, that's good. I'm also in the media. So I just brought a couple questions, and hopefully that will advance our thinking. Just to refresh your memories, we have Dipankar, we have Karsten, I'm Scott, this is Kim. The first question that I would love to toss out is just, you know, a little bit of your definition of what exactly is next generation design, what's changing about design in 2023. Dipankar, why don't we start with you? You were the first panelist to show up today, so
okay.
you get the
lucky
first
me.
question.
Lucky me. So I'm going to comment on that from the lens of my specialty and the company that I work for, which is Ansys. Ansys focuses on physics-based modeling and simulation. So everything to us looks like modeling and simulation. I was at lunch with somebody on the table and their fork broke, right, when they were pressing down. And the first thought that occurred to me was stress concentration loading, whereas he came up with bad choice of design, right? And that's the main issue. So I would say that to me, it's designing is in the hand of subject matter experts, like in this audience. And what we can do as technology and software providers is provide the tools that help accelerate that process, that help augment it. And there are many exciting technologies on the horizon right now that are hoping to revolutionize that.
Yeah. So Karsten, you're also kind of in the world of simulation. For you, like what is, when I say next generation design, like what bells does that ring for you?
Well, what we at Apriori think about a lot is factoring in additional constraints. I mean, so similar to the way like you would look at strength and fatigue or like a flow analysis, we want to be able to factor things like cost, manufacturability, sustainability, carbon offsets into the design. And I think one of the great things about this next generation of design is the abilities to have tools and to allow designers to factor all that in and really make decisions that are informed by all these different constraints. Where in the past, maybe it was just form, fit, function. Now there's what's my carbon impact, where am I sourcing my materials, how good are my suppliers, what's the quality, what's the risk. So providing tools and building tools and strategies to make that much easier. Yeah.
I love it. I have one question for AV, which is if it's possible to turn up the monitors a little bit just so we can all hear each other, that would be awesome.
Yes.
It's kind of I don't know if you've noticed, this is a cavernous room. The last time I was here was, I think, to see the immersive King Tut exhibit, and it worked really great for like immersive Egyptian tombs, not so well for panels. So Kim, you work for this giant furniture company based in Michigan, Steelcase, that we've all sat in your product. Lots of designers at Steelcase. When we say next gen design, like, what would you say to kind of provoke this audience that they may not think about?
Especially my work, I lead ESG, all of our people and planet commitments and goals throughout the organization, and for multiple stakeholders that we adore. And so many of you that I've talked to already today here talk about how all of your customers, how all of your stakeholders are actually pushing design in new and different directions, maybe at a differing speed, then your organizations are ready to respond. And I think right now, when we think about next-gen design strategies, it's really understanding that push and pull of understanding what customers are trying to do and meeting their carbon commitments, like you were talking about, what customers are thinking about when they're planning their own sustainability goals, or what that means when you're sourcing materials throughout the world. So I think the next-gen design strategies really are rooted in the choices that we make around people and the choices that we make around the planet. And with this landscape being so incredibly fragmented, not a lot of standardized processes to be able to measure, disclose all of these kind of complexities that we have, while also balancing out the needs of the new workforce that aren't just asking for these aspects of design, sustainable design, life cycle analysis. They're requiring that from their employers because they want their values to actually match their own. So I think there's a lot of different pieces and parts in that process.
Since you mentioned ESG and we were talking a little bit about sustainability earlier in this conversation, like, if I were to approach this as a skeptic, right, every company has this ambitious goal around whether it's the Agenda 2030 kind of UN SDGs, whether it's a sustainability goal that they've set. Like, every company has an ambitious goal that they want to hit, but sometimes it can feel like there's not a whole lot of urgency. Like, what have you seen about companies trying to dial up the urgency around achieving these goals?
Yeah, I was just reading Autodesk's new research and the insights that they had in their publication that they have over there. If you haven't picked up a copy, it's really, I think it's really interesting and telling. Part of the research that I was just looking at that they published was that something like 80% of companies have already set their own sustainability goals or moving towards their target. But exactly what you're saying. They're doing it because they're staying the course, but they don't feel the urgency to accelerate.
Or sometimes they're not resourced, right? They don't have the people that they would need to achieve that goal, right? You have well-meaning employees, but not well-resourced.
And so when we think about sustainable design, when we start thinking about that next-gen design strategy, the urgency may feel like now we're staying the course, we're doing our scope 1, we're scope 2, into our supply chains, our customers into scope 3. But the pressure really is going to be on those farther horizons. And the companies that don't integrate the urgency are the ones that are going to be left behind, because that innovation is incredibly integrated into those strategies for people to succeed in those farther horizons.
I want to shift a little bit to generative AI because I was at earlier today a conference over in Cambridge about generative AI. I feel like generative design is certainly a term that has been bouncing around. I probably heard the first generative design presentation, in my life maybe 10 years ago at Autodesk in San Francisco, right? So they were already talking about this as a possibility. How do you think generative AI is already or will play into the design, manufacturing, prototyping process? Or sorry, prototyping, manufacturing. Mix things up there.
I think a couple of different areas. I mean, one way I think about it is just the ability to explore a lot of different options and a lot of different constraints. So for example, I think from a design side, the generative design tools that Autodesk has in Fusion and some of their other tools allow you to explore all different ways of making a particular part within the sort of load constraints that you apply to it. And then you can extend that to other constraints, like where should I source this particular assembly or this part that gives me the lowest carbon impact? Where should I where's the lowest cost region to manufacture something? What's the risk versus nearshoring versus offshoring in terms of the lead time? So you're balancing all these different constraints, and I think generative AI can really help sort of analyze all these different options and get to a sort of a good decision faster.
Do you feel free to build on that answer, but then I also have
I just wanted to build on that, Scott. And you mentioned you came from a conference on generative AI, so see if this makes sense. I tend to think of new technologies, and not just generative AI, but in general, it maps well onto this Gartner hype cycle. I think you may have seen this curve, right? There's an innovation trigger, unreasonable expectations, a peak, then a trough of disillusionment, then steady progress and productivity, right? So in my opinion, I think thanks in part, great part to Autodesk, generative AI is in design is sort of at the threshold there. Gartner thinks it's 4, 5, 7 years from production usage, but in my mind, the tools are coming together because if you have a population of data and information that's driving the design candidates, and then you inform that with the built-in physical and mathematical modeling that we have all perfected over decades, right? Then you have both data-driven and physics-driven inputs that's driving the generative AI process. So I think this combination, this fusion of technologies is going to push it over the threshold, in my opinion.
Do you also think it like potentially democratizes even further? I mean, like, hey, the world of 3D printing and kind of low-cost 3D printers democratized prototyping in an incredible way. Like, does generative AI democratize the design process of physical things in a new way? Like, you know, I think about the way OpenAI suddenly, you know, all of us can write sonnets with a quick prompt, you know, like write me a Shakespearean sonnet about traffic on a Wednesday afternoon in Boston, you know, and you get something pretty good. Is that going to impact the sort of accessibility of designing physical stuff?
I think so, potentially, yes. I mean, one of the aspects of, like, if you're not, design is a learned skill, so if the tools might be able to help you sort of get to a design answer faster or make choices better in terms of, like, okay, what is the right material to use for this part? And often, like, when we talk to customers, when you just ask a group of designers, okay, what do you think this part costs or how much carbon is in it, you get 10 different answers from 10 people. So with the sort of generative AI tools, you can increase the sort of understanding and close some skills gaps or get to alignment between different designers of different skill levels.
I think that's a terrific point. You know, the question is, for who is this technology and method, right? It's for the designer. I had this little epiphany in the washroom. I don't know how many of you use the somewhat strange faucet in the washroom. And I was thinking, okay, fluid mechanics in action, modeling and simulation. But at the end of the day, it was a design, right? And somebody put it together. That same company makes excellent vacuum cleaners, but it resulted in a non-optimal faucet design, right? And dryer. So, I mean, generative AI and methods like that will provide excellent information, informed information perhaps, right? Driven by modeling, simulation, etc. But at the end of the day, I don't think it replaces human expertise in a way, at least not in the foreseeable future. So it's important to keep in mind who consumes that information.
Mm-hmm. Yeah. Kim, you travel the world, right, speaking to audiences and visiting different Steelcase sites. Like, you know, Dipankar brought up the Gartner hype cycle on AI. Are you feeling like, are we at a peak of hype, or do you think this is something that kind of sustains and like the generative AI revolution is, you know, is here, is going to be deploying into lots of jobs and lots of organizations?
Yeah, I wish I had the answer for that. I think all of us wish we had the answer for that. I think it's too early to tell for a lot of the reasons that you just outlined. So many of the designers, they're designing for the human condition. Like each and every one of you are designing and manufacturing and doing all of these beautiful things that are informed by each and every one of you and the communities that you serve. When you think about AI as a tool, it's past looking, not future looking, and all of those inputs come at a time where maybe the governance of this is just not vetted enough to get the scale that we need. That being said, you know, we've explored that. We've taken a look at that. I remember working one of our design directors, and he was showing and explaining how generative design looks, and it just disrupted kind of ideas about what was possible. So from he was looking at it from an aesthetic design perspective, and seeing kind of new models emerge and different ways to redistribute like weight and tension and all of these beautiful things. It was a moment to actually imagine something different.
Yeah.
And for those moments and those sparks of imagination, absolutely. I think everyone's just in that curiosity phase, but to actual standardization or having the governance and ethics behind it right now, I just don't think the world is there yet.
Yeah, but I like the point that you're making, which is one thing it can be good at is like sparking your thinking, provoking you, even when it's bad, right? Like it makes a room full of people think differently about the problem that they're looking at. And I feel like we've all probably been in those rooms where it's just, you've circled the problem so many times and nobody seems to have, a fresh take on it.
That's right.
Everybody's bringing their their favorite hobby horse issue or design strategy to it. I'd love to talk a little bit about, processes that you think are going to become much more automated going forward, or like parts of the design, prototype, manufacturing process that you just think are going to be disrupted or, or changed in some way. Karsten, why don't you go first?
I think some of the first areas where we've seen it, on the software engineering side and in my job in software companies, is maybe more some of the routine tasks, like a lot of creating a case study or creating a white paper or generating a report that summarizes sort of like I have some different design options, now I need to make it look good to report to the review team. So all of that is there's already tools out there today that will do that for me almost automatically. Mm-hmm. So I think one process improvement is just saving the design engineer's time or the engineer's time, and sort of like they can focus more on creative tasks, and they can sort of have ChatGPT or something equivalent do the reporting and summaries for you. So hopefully, routine tasks I think is a great benefit in terms of just freeing up users. Engineers still spend a ton of time just looking for stuff.
Yeah.
And looking for the right part, looking for the right fastener, valve component to fit into their assembly, their design. So as those tasks get sped up, then it opens up more of their time to just be creative and come up with new ideas like that Dyson hand washer.
Yeah.
Yeah.
No, I love the idea of people getting busy work and routine work off their plates. I ran into an entrepreneur on my way in here who said, hey, ChatGPT is fantastic when you have an RFP that's asking you like these really basic questions that you don't want to spend an hour answering. Get ChatGPT to do it. Are there any tools, before you move on, are there any tools that you have in mind that are worth mentioning other than ChatGPT?
Yeah, in terms of just applications of AI, I think we see a lot of opportunity in terms of understanding the best practices around design or sort of learning from, okay, we've looked at sourcing tens of thousands of sheet metal parts, and out of that we've learned, okay, how do we optimize how we sort of group these together onto a sheet to manufacture, to minimize waste, to minimize, so optimization, I think, is a huge area of opportunity, or filling in data gaps is another one where we're using past information to inform like a brand new part coming in and understanding, well, okay, is this a casting? Should it be a sheet metal part? Should it be machined? Mm-hmm. So we can learn from how we've treated similar items in the past and then apply that. So I think there's some excellent applications in optimization and sort of learning from sort of past analyses.
Dipankar, I'm curious, like other thoughts about tools that you're seeing growing in importance, or just ways that the process is going to be disrupted or changed?
Yeah. So I think that's an excellent point. It's probably a combination of both. The tools that are used, I'll just pick on modeling and simulation tools because that's my space. Traditionally, they have moved from an analyst profile type of user, somebody who's deeply specialized in a particular area in physics modeling, into the hands of designers. And that has to do, I believe, with certain improvements in a bunch of allied areas. So for example, the tools themselves, how democratized are they? How robust are they? Are they useful in terms of providing the key information to the user, right? And then how do they live in the ecosystem of the whole design flow, right? By this I mean the information that's produced by these tools, let's call it computational tools, how are they published into the process that the designer may use? And by this I mean sometimes the turnaround time is the bottleneck, right? It might take days to actually run one of these industrial scale simulations. That has changed a lot with methods improvements, with high performance computing, how high performance computing is deployed on the cloud now, right? So all of these are contributing to, I believe, a compression of that overall process. Sometimes these very expensive calculations can be published as a reduced order model that becomes part of an overall digital twin system and therefore real time, right? So I think there are a whole bunch of contributing factors. And last but not least, coming back to an earlier point I made, where there is opportunity to combine synthetic data produced by simulations with real data, operational data, or measurements, but do it in a kind of complementary fashion. I think that's led to a lot of process compression as well.
Yeah, I feel like I won my AI bingo card because synthetic data was also a big topic at this conference over in Cambridge today. So I want to be able to check off all the AI buzzwords. RAGs, there's some AI acronyms too that are bouncing around. LLMs, obviously. Just to go back though, it sounds like when you say compressed, you really mean like, man, a lot of stuff is being front-loaded earlier in the design process. Like,
yes.
There's a lot more happening, that it's not quite the old school, like, stage gate based, like, oh, I pass it from department A to department B to department C.
Yeah.
Am I reading that correctly?
Yeah, absolutely. So that's what we hear from our customers. If they're able to bring these methods and tools earlier in the design cycle, then there is much more opportunity to compress that overall time to market, but also make it higher quality and error-free, right? Or as error-free as possible. There's one key aspect I forgot to comment about, is that many of our tools, which have been in existence for decades, I think have done a very poor job in informing confidence level in the results, right? So now I'm sort of veering more into quality, uncertainty quantification, verification, and validation. I think tools are getting much better at providing some intervals of which that design is a viable design. I'm really talking about what was called robust design before, right? Providing quantitative measures of how good a design is. So all these combination of factors leads to more trust in these tools and methods being used further upstream.
Got it. Kim, I'm curious to ask you just kind of this process question, right? Like we're here talking about the design to manufacturing process. What else do you see? And we've talked about this kind of front-end compression, just how much work is happening really early in the design process. Obviously sustainability is something we've touched on, but like what else do you see is getting automated, is becoming irrelevant, is changing about the design process as we head towards 2024?
Yeah, I think from my vantage point, and I'm not in the PDNL process like so many of the other makers and designers are, but I work with them really closely on the actual sustainable design process. What are those guiding principles? What are the scaffolds? What we're seeing is the lack of integration of the tools being able to speak to each other, and then having a lack of a common understanding of even just baselines. So what we did at Steelcase is we launched this Project S. So it's a sustainable design project across our entire value stream, all the way from research and idea into design and engineering, all the way through. And we found that so much of the tools couldn't handle or cope with all of these new ideas that these young designers and engineers were trying to input within the systems to try to get it to market. because it was based on some of these older models or some of these older assumptions. So I think when we think about disruption of this, we can think about the process disruption, which I think there are going to be a lot of inputs that are going to have to shift and change to measure things like carbon impact, embodied carbon, all of these things that your clients and you as companies are looking at. But we also have to think of the next generation of users of those systems and how they're rethinking kind of those daily behaviors and thought processes, embedding these new things like sustainability within there. The other thing is kind of the ethics behind all of the processes. So you talked a lot about the democratization of both knowledge and information. So when we're thinking about this, this is where the AI, where a lot of these tools can actually be used as a force for good when we think about democratizing this type of information. So you have a little bit more of a generalist profile within the engineers and designers, so each of them can have the capacity to work collectively and not just within their silos. So I think those are the big shifts we're seeing.
Cool. I definitely think you touched on like one of the unsexy things, which is like how there are just so many data silos, like in any company. Like once you actually start talking about where does the data sit and start trying to leverage it, right, with AI or other kinds of tools, you get into the really messy stuff that's not fun to talk about on panel discussions.
I know.
Interoperability standards.
And you know, so much of the work that's been done, there's data out there. There's a lot of data, and every team has their own data lake. But it's the sense making. It's that collective sense making of the data that when we see the acceleration of that, these higher level things that AI could potentially have a place in, I think that's where we're going to see the system be disrupted.
Great. Just, I guess, to touch in our last few minutes together on the manufacturing, on kind of like the enabling different kinds of manufacturing, smarter manufacturing. Like, I'd love to hear your thoughts on where you see that going. You know, once we get to the rubber meeting the road, and like, okay, we have something that we're ready to scale up. What you see changing, you know, try to provoke this audience of experts a little bit to maybe think differently about manufacturing.
Well, one aspect I think is the sort of much more sort of realistic or like matching the physics and matching the true sort of aspects of the manufacturing processes. I mean, leveraging AI, leveraging computing technologies, cloud computing, different simulation models, so you get a much more realistic view of like what would it take to manufacture this part with additive, as a casting, as a sheet metal or machined. So that really helps, I think, make the right decision and understand every aspect of the manufacturing process, like is it sustainable? Is it generating a lot of wastewater? Mm-hmm. Is it cost too much? Does it take too long? So I think that's a big part of it, is just making it more realistic in terms of the models that you can generate these days. And I think the other, I mean, there's just more and more different process choices out there. I see that accelerating a ton with a lot of the additive processes that you see in the market. So I think one of the aspects that we're trying to do is sort of tighten that loop, so as these processes enter the market, it's easier for customers and users to discover those and start saying, well, what if I tried this process and how does that map against things I've been using for 20, 30 years. So I think one big sort of mission would be sort of try to sort of tighten that loop between the manufacturing technologies that are evolving and the design tools leveraging them.
Dipankar, thoughts on that?
I'm sort of the least qualified person on this panel. You know, they put me in the boiler room doing equations for a reason. So I'm the kind of engineer.
Away from the factory floor.
I know, but when I met my wife, she thought she was marrying a mechanical engineer. And I said, well, I could explain all the theory, but I couldn't be of any use around the house. No, but on a serious note, I think Carsten's had a very thorough response to that. But in terms of enabling smart factories or the overall vision of the digital transformation from start to finish, I think what we see in our customers and you know, in this conference as well is this theme of following that thread, right from the initial concept, design concepts, the ideation, all the way through to manufacturing and manufacturing processes, operational data after that, and then looping that back into that overall process. So following the digital thread and following and taking all the technical innovations that enable that, it's not easy, but once it's accomplished, we've seen it in scale in aerospace and defense first, the whole implementation of model-based system engineering as it gets into manufacturing. I think that is a big change. Hopefully that'll come into other
Yeah, you seem pretty qualified to answer that question, in my opinion. I mean, I guess I want to ask a last question, just kind of a jump ball for whoever wants to answer this for me, which is, you know, when I see what Hasbro is doing with the kind of, you know, mass customization of the action figures, right? That's a concept that people have been talking about at least since the mid-90s, right? That, oh, mass customization is going to be everywhere. You know, this jacket, your watch, everything, you know, is going to be an N of one. And I also think that, like, in the last couple of years, during COVID and as we come out of COVID, you know, with all of the supply chain issues and the tension between the US and China, like, people are looking for how do we get more flexibility, more onshoring? Like, are there ways that you think that, you know, there's a lot in this question, but are there ways that you think manufacturers, design is really, you know, innovating at a pretty rapid pace, right? But, like, are there ways that you think the manufacturing end of things is going to change, either for that more flexibility in how much you're ordering, how much you're producing, more of those mass customized products? Like, I'm curious if you have predictions there.
I mean, one interesting sort of aspect of it is like, for a long time, companies were pushing over just-in-time manufacturing, but at the same time relying on a very global supply chain. And so as soon as there's some disruption to the supply chain, just-in-time manufacturing can break down very fast, as we've seen. So I think one benefit that we see in a lot of conversations have been around, like, how do we possibly reshore or build skills, like distribute more skills, like Hasbro, I think, or, well, was, I think, a later panelist that talked about building 5 new factories in 5 different regions. So I think we'll see more of that in terms of just more
trying to get production closer to the market.
Distributed flexible capacity to get production closer to the market. Yeah.
Kim, Dipankar, other thoughts on that jump ball question? It's okay. It's okay if you don't have thoughts.
It's a great question.
I don't want to press you. We're just about out of time here. I don't think there are microphones to allow you to answer questions, but I would encourage you to come up and talk to these panelists afterwards. We all felt like, okay, we would love to get some questions from the audience, but the venue's not set up for it. So please help me thank Kim, Karsten, and Dipankar for spending time with us today. Great job.
Thank you.